Welcome back to statistics. In descriptive statistics, our goal is to describe and understand a data set. Oftentimes, this comes down to graphs like histograms and bar charts that give us an idea of the distribution of a statistical variable. But there are also numerical techniques for describing a distribution. By this we mean giving a number or a set of numbers that describe the main features of the distribution of a variable. And in this video, I want to talk about numbers that describe the center of a distribution. The center of a distribution, in some sense, gives us an idea of what's typical of the values of that distribution. So let's take a look. We are now actually in Module 4 of our text, and the module is going to be kind of extensive because there are a number of different numerical descriptors of a distribution. We're going to start in the first subsection by looking at measures of the center of a distribution, and these are the mean, the median, and the mode. So let's take a look at the key concepts. The mean of a data set is probably the most familiar measure of center for a distribution. There's a little formula here we give for the mean. We'll always denote the mean of a set of sample data by x bar. If the variable is x, the mean of that data would be x bar. Sometimes we'll use different symbols, like if the variable goes by the name of y, then the mean of the data would go by the name of y bar. And the little formula here is just mathematical shorthand for what you already know. To calculate the mean of a data set, you sum all the data up, and then you divide by the number of data points. So this little symbol right here, this Greek letter sigma, let me see if I can blow that up. The Greek letter sigma here just stands for sum. X just stands for your data, so sum your data and then divide by n, the number of data points that you have. So that is the mean. We've been familiar with that idea ever since we could, average out our own test scores and see what our average test is. So it's a very familiar idea. That's a measure of center of a distribution. Another measure of center for a distribution is the median. The median is essentially the 50% point in a data set. So if you imagine sorting the data and then finding the very middle of that sorted data, that middle value would be the median. Now, sometimes the middle value actually falls right between two data points, and in that case, you just average the two data points that bracket the middle. And that, of course, depends on whether there's an even or an odd number of data points. So the median is another measure of center. And then finally, the mode. The mode of a distribution is the value that appears most often in the data. And so this is not really usually considered a measure of center. It may actually be an extreme value in the data set, but it is included by our text in this section, so we'll go ahead and talk about it too. So let's take a look. In their first example, they give us the ages of people attending a meeting. They give it to us here as 27, 42, 35, and so on. And so this is our sample data. What would be the mean of this data? What would be the median? And what would be the mode? Well, let's just take a look. First, the mean. We're going to compute that just as you think. We simply add up the data points and then divide by the number of data points. So we have 7 data points here, and add them up, divide by 7, you get 36.1428 and some change. A rule of thumb here about the number of decimal points to keep in these computations, because when you calculate a mean, the division is going to mean that oftentimes you get a whole slew of decimal points. But you don't need to report all those in your answer, because most of those are going to be really not that meaningful in terms of the precision of your original data. For instance, in this case, our original data was originally given to us as whole numbers. When we divide by 7, we get a bunch of decimal points, but really, you don't want to report this at that full accuracy in a statistical sense, because then it's almost like you're misrepresenting the data. It's almost like if you report the mean as 36.14285714 years, then it's almost like you're claiming that the data was given to you at 8 or 9 places of accuracy, and that wasn't the case. A good rule of thumb is just to give one extra place of accuracy when reporting the mean, and that's what they do here. Since the data was given as whole numbers, we calculate the mean and then report it with one extra decimal place of accuracy. So round that number, 36.1428, blah, 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 and report that it's 36.1. That's the mean age of the individuals in the sample. What about the median? Well, here, the data was not given to us originally in sorted order. If you look back up here, it was just given to us in the order in which it was observed. To calculate the median, it's helpful to have the data sorted in order. So that's what they've done here. Now the data is sorted, and the median is the 50% point. You can almost just eyeball it here, right? It's 36 because there are 3 data points to the left and 3 data points to the right. Half the data is less than 36, the other half is greater than 36. So the median would be 36 years. In larger data sets, it's a little harder just to eyeball it, but there's a simple rule. If you think about numbering the data, 27 is our first data point, 35 is the second, 35 is the third, and so on. You have 1, 2, 3, 4, 5, 6, 7. 7 data points. The median is going to be in the midpoint position of those. So the midpoint between positions 1 and 7 would be 1 plus 7 over 2, right? Just calculate the average. So 1 plus 7 over 2, that's 8 over 2, that's 4. And sure enough, 1, 2, 3, 4. That is the position of the median. So the position of the median here is position 4, and the value of the median is 36. And then finally, the mode. The mode is the most frequent value in the data set. So in this case, the mode would be 35. So we have a mode of 35, a median of 36, and a mean of 36.1. Notice that these 3 different measures don't give the exact same answer. So there's, the mean and the median will often be different, and the mode may be different as well. I want to point out at this stage too that the mean and the median both require that the data be quantitative, right? To calculate an average, you need to be averaging quantities, averaging numbers. And to calculate the median as well, you need to have data that you can sort in order. So the mean and the median both presuppose quantitative data. The mode does not. You could actually use the mode to talk about categorical data too. And so the mode is a little bit different than the other two here, but again, we're going to talk about it as we go forward. Let's take a look at a couple of their examples. I think I wanted to look at the commuting times in the Big Apple. So here is a data set consisting of the commuting times in minutes of 20 employees, and I believe they're from New York City. And they just ask us to find the mean, the median, and the mode. So the data are given to us in sorted order. To find the mean, we would simply add up all those values and then divide by the number of values we have. So if you add them up, you get 830, divide that by 20, and you get the mean of 41.5 minutes. The median would be the center point of that data set. Now you can even eyeball this one, but let's think our way through it in a different way. There's 20 employees, and so the first one, the smallest commute time, would be in position 1, and the largest commute time would be in position 20. So what's the position of the median? 20 plus 1, in other words, I'm taking the average of the positions here, position 1 and position 20. The average of those two is 21 over 2, or 10.5. So that means the median is between items 10 and 11, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. These two guys right here, the median is right between them. And so in a case like this, you would average the two values that bracket the median. So the average of 45 and 45 is, again, just 45. And so the median would be 45 minutes. Notice that the median in this case is a little bit bigger than the mean. The mode, the most frequent value, is also 45 because it occurs 5 times. Some other values are repeated, like 60 is repeated 3 times, and so is 30, but 45 is the mode because it recurs most frequently. So the mean, the median, and the mode are going to be 3 measures of center, or measures of typicality, that we're interested in, and we'll be combining those with other measures like measures of spread or variation, to get a numerical summary of a data set. And we'll pick up on those other ideas in our next video. In the meantime, y'all take care, and we'll be back at you soon.